It jammed at the worst possible moment. It killed its own users through accidental discharge. Soldiers called it the Plumber's Nightmare or the Stench Gun. By every standard of precision engineering, the Sten Gun was a piece of junk. But in 1940, Britain didn't have the luxury of precision. After Dunkirk, 500,000 rifles were sitting in the French mud, and an invasion fleet was gathering across the Channel. With 6 months to rearm a nation, good enough was the only metric that mattered. This is the audit of the £2 weapon that traded quality for survival. From May the 26th to June the 4th, 1940, at Dunkirk, the Miracle of Dunkirk evacuated 338,000 British and Allied soldiers from the beaches of France. They got the men out. But here's what they left behind. 2,472 artillery pieces, 63,879 vehicles, 76,097 tons of ammunition, over 500,000 rifles and machine guns. Britain had successfully evacuated an army, but that army had no weapons, and Britain was broke. The Battle of Britain was about to begin. Invasion seemed imminent, and the question wasn't tactical. It was logistical. The British Army didn't need a precision instrument. They needed a mass-produced miracle. The question wasn't how to make the best gun. It was how to make the most of them. This is the audit of the £2 Sten Gun. The answer was a stamped metal tube that cost £2.50, jammed constantly and occasionally shot its own users. It was ugly. It was unreliable. It was dangerous. And it may have been the most important weapon Britain produced in World War II. This is the operational assessment of the Sten Gun. After Dunkirk, Britain turned to the United States for help. America was willing to supply weapons, but there were problems. The Thompson machine gun was an excellent weapon, reliable, well made, and proven in combat, but it was also expensive. The cost of one Thompson submachine gun was approximately $200, which in 1940 equated to 50 British pounds, and it was slow to produce. Machined from solid steel with tight tolerances and complex parts. Britain needed weapons now, and they needed them in massive quantities. Let's do the math. British Army strength post Dunkirk, 1.5 million men. Available budget for small arms, limited. Thompson submachine gun cost £50 per unit. The amount of Thompson submachine guns Britain could afford, maybe 200,000. Actual need, millions. The Thompson was a luxury Britain could not afford. The US Lend-Lease programme wouldn't begin until March 1941, nearly a year after Dunkirk. Britain could not wait. They needed a weapon they could produce themselves immediately and cheaply enough to arm an entire civilian resistance if invasion came. The solution wasn't going to be elegant. It was going to be emergency engineering. In 1940, two men were tasked with solving the impossible problem. Major Reginald Shepherd and Harold Turpin, working at the Royal Small Arms Factory in Enfield. Their brief was simple. Design a submachine gun that can be mass-produced in workshops, bicycle factories and small machine shops across Britain, using the simplest possible methods. Forget craftsmanship. Forget elegance. Forget reliability if it slows production. Maximise output, minimise cost. The design philosophy of the Sten was that it was built on 32 stamped metal parts. Minimal machining, minimal welding, minimal finishing. The barrel was a simple steel tube. The receiver was a stamped sheet metal. The stock was of skeleton frame of welded rod. Production time was about 5 hours per weapon. Compare that to the Thompson, which required weeks of skilled labour. The cost per unit, £2.50. That is 1/20th the price of a Thompson submachine gun. The Sten Gun wasn't named after a heroic battle or a general. It was named after the engineers and the factory that designed it. Because this wasn't a weapon designed for glory. It was a weapon designed for volume. The Sten Gun worked. Barely. But it had 3 systematic flaws that made it notorious among the soldiers forced to use it. I've handled weapon systems across 4 decades, from Northern Ireland to Afghanistan, and I can tell you, emergency designed weapons always fail in predictable ways. The Sten's 3 flaws weren't accidents. They were calculated trade-offs. Flaw 1. The magazine. The Sten Gun used a single column feed magazine copied from the German MP-28. Ironic, given it was meant to kill Germans. But the British version had a critical weakness. The feed lips were made of soft stamped steel. If the magazine was dropped, stepped on or even loaded roughly, the lips would bend just slightly, and that slight bend meant the rounds would not angle correctly into the chamber. Result, a failure to feed. The gun would jam in combat. Magazine reliability is the Achilles heel of every emergency designed weapon. The same issue can be seen in hastily procured AK variants, in captured weapons pressed into service, in anything built under time pressure. The magazine is always the weak point because it's the most complex interaction of spring tension, metal fatigue and user handling. The Sten Gun just made this weakness visible. This wasn't a rare problem. This was the primary failure mode of the Sten. 80% of Sten Gun stoppages were magazine related. Soldiers learned to treat magazines like glass. Here's where it gets worse. The Sten's ergonomics encouraged soldiers to use the magazine as a forward grip. It stuck out from the left side of the weapon. It was the most natural place to put your support hand. But gripping the magazine put lateral pressure on the magazine catch, tilting the feed lips and virtually guaranteeing a jam. The gun didn't fail, the ergonomics failed. British armourers developed a magazine filling tool to help maintain the feed lip angle. But the real fix came from the field, the 28 round rule. The magazine was rated for 32 rounds. Veterans learned to only load 28. Why? Because reducing spring tension meant less pressure on the feed lips, which meant less deformation over time. When your weapon's primary operating procedure is don't use it as designed, you know they've made compromises. Flaw 2. The safety, or lack thereof. The Sten was an open bolt weapon. This meant the bolt sat back when the gun was loaded, slamming forward when you pulled the trigger. Simple. Effective. Also dangerous. The issue. If the gun was dropped butt first onto a hard surface, inertia could pull the ball back far enough to pick up a round from the magazine, but not far enough to engage the sear. The bolt would then slam forward, firing the gun, without anyone touching the trigger. This made the Sten notoriously dangerous during transport, parachute jumps, any situation where soldiers were moving quickly. Soldiers died from their own weapons going off accidentally. The fix. The Mark IV safety. A simple modification. A hole was drilled into the cocking handle slot, allowing the user to push the cocking handle through the receiver, physically locking the bolt into the forward position. It worked, but it took years to retrofit existing guns, and many early model Stens remained in circulation without it. Flaw 3. Overheating and fouling. The white hot problem. The Sten had no barrel shroud, no cooling fins, nothing to dissipate heat. The issue. During sustained fire, the barrel became white hot. Heat caused the thin stamped metal components to expand. The bolt would stick mid-cycle. Stoppages. In the middle of a firefight. And because the gun had no handguard, soldiers couldn't even touch it without burning themselves. The temporary fix. Soldiers learned to fire in short bursts and let the gun cool between engagements. Not ideal when you're under enemy fire. The real fix. The problem was never truly solved until the Sten Mark V, the so-called luxury Sten, which added a wooden pistol grip, a wooden stock and a front handguard. These weren't cosmetic. They were functional solutions to keep soldiers from burning their hands off. But the Mark V didn't enter service until 1944, 4 years after the Sten was introduced. For most of the war, soldiers just dealt with it. The most famous jam in history. May 27th, 1942, Prague, Czechoslovakia. Josef Garbčík, a Czechoslovak resistance fighter, waited in ambush for Reinhard Heydrich, the architect of the Holocaust and now known as the Butcher of Prague. Heydrich's car approached. Garbčík stepped into the road, raised his Sten Mark II, and pulled the trigger. Click. The gun jammed. Heydrich's driver attempted to speed away. Garbcheek's partner, Jan Kubisch, threw a modified anti-tank mine that wounded Heydrich, who died days later from infection. But the moment is burned into history. The StenGun's most critical shot, and it failed. Or did it? Here's what an operational assessment reveals. Garbcheek had been waiting in position for an extended period. The StenGun was an open bolt weapon with no dust cover. Debris entry during a long static position is a predictable failure mode, not bad luck. The gun performed exactly as its design suggested it would. This wasn't a weapon malfunction. This was improper employment of a weapon system beyond its design parameters. Modern reconstructions confirm the magazine was likely overloaded, 32 rounds instead of 28, or debris had entered the open bolt during the long way. This single high-profile failure cemented the StenGun's unreliable label forever. We've looked at the birth of the StenGun, the plumber's nightmare that cost £2.50, the fatal flaws in its design, and the high-profile failures in the field. History rarely gives you a second chance when your weapon jams at the wrong time. So, how do you take a weapon that's unreliable by design and actually win a war with it? In the next part of this assessment, we're going to cover the workarounds. We'll dive into the legendary tap drill, a 3-second sequence that soldiers were drilled on until it became muscle memory. We'll also look at the contrarian tricks that soldiers used to force these guns to feed, and why those same techniques are still being taught in the military today. And finally, we'll move beyond the British Army to see why resistance fighters across occupied Europe didn't just accept the Sten's flaws, they embraced them. The audit of the StenGun is only half finished. The second half of this assessment is coming soon. When it does, you'll see how the British Army trained their way out of a logistical disaster. If you enjoy these audits of history, hit the like and subscribe buttons. It only takes a second and it really helps the channel. I'm Gavin Wilson. This is the Contrarian Chronicles. File paused.